In this lecture, we're going to explore the idea that we can do polymorphism at different levels in our inheritance hierarchy. Suppose we have a hierarchy like we see here. The top level class is animal, and we can derive from animal and create a feline animal. We can derive from feline and create a dog animal. We can derive from feline, create a cat animal. We can also do it the other way and create a bird, which is also an animal. A bird is going to have its own methods and member variables that make it a bird. We can derive from a bird, create a pigeon, and we can derive from a bird and create a crow. And we can do all these things that these animals do. So the idea I want to expose here is that polymorphism doesn't have to always only work on the top level class. If you have an inheritance hierarchy like this, if you want, you can declare a virtual method at the feline level and make sure that method is also available in deriving class, and you can set up feline polymorphism if that makes sense for your application. Following the same idea, you can also set up a virtual method in the bird class, and you can have that method overridden in downstream inheriting classes like pigeon and crow, and you can set up bird polymorphism in your C++ program if that makes sense. Of course, you can still use animal polymorphism if you want to do that, and that's going to work as well. This is the idea we're going to explore here. Okay, so with that inheritance hierarchy in mind, we can create animal polymorphism. And animal polymorphism is just going through the animal base pointer and using that to manage derived objects. For example, here we have a dog, we have a cat, we have a pigeon, we have a crow. We can do animal polymorphism and storing any kind of animal we have here. You see, we are putting in a dog, we are putting in a cat, we are putting in a pigeon, and we are putting in a crow. And if we do animal polymorphism and call the breathe method, which exists in any kind of animal we have in our program, this is going to call the most specific breathe method on each animal, and this is going to work really well. This is going to do animal polymorphism. Following the same idea, we can also do feline polymorphism, and in this case, feline is going to be acting as our base pointer. So again, we have our dog, we have our cat, we have our pigeon. If we do feline polymorphism, we will have to put in all kinds of crazy felines we have in our program. For example, we can put in dog and cat, and this is going to work. If you do feline polymorphism like we are doing here and put in an animal, this is not going to work because the animal top level class is probably not going to override the virtual method we are interested in here. For example, here we are calling the run method, and the run method is not set up at the animal level. Let's go back and look at our inheritance hierarchy here. You see, this is our animal class. Our virtual method is going to be breathe because any kind of animal we have is going to need to breathe. But the run method is set up at the feline level. So if we try and store in an animal in a setup that uses feline polymorphism, the run method is not going to be available and we're going to get a compiler error. So I want you to know this, but we will also see this in a minute when we hit Visual Studio Code to really play with us. Okay, we can also do bird polymorphism, and here you see we have two objects. One is a pigeon, the other is a crow, and we're going to do bird polymorphism here, and what that means is that we will use a bird pointer to manage all kinds of crazy birds in our C++ program. For example, we can use that to manage a pigeon, we can use that to manage a crow, and if we loop through our birds and call the fly method, the most specific fly method is going to be called. In this case, at the first iteration, we're going to call the fly method on our pigeon object. At the second iteration, we're going to call the fly method on our crow object here. And this is going to work. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is polymorphism at different levels. We're going to grab our template files. Let's grab it all. We're going to copy this and put this in our current project. And we're going to open this little guy in Visual Studio Code like we always do. And before we open this up, I am going to put in the classes I have lying around on my drive. And these are going to be the classes making up our inheritance hierarchy here to make things go faster. If you want, you can grab these classes from the attached resource section on this lecture. You're going to find all these files. You can download them and put them in your project and use that as a starting point. Because you don't really want to be creating all these classes, this is going to just waste your time. The basic idea I want to expose here is doing polymorphism at different levels. So we're going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us our good starting point. You see we have a bunch of classes in here, but all these classes are really trying to set up the inheritance hierarchy we have here. The top class is going to be the animal class. We can derive from animal and create a feline class, and we can derive from animal and also create a bird class. We can derive from feline and create a dog. We can derive from feline and create a cat. And we can also derive from bird, create a pigeon. We can also derive from bird and create a crow class. And at each level, we're going to have a virtual method that we set up that other deriving classes can call through polymorphism. For example, if we do animal polymorphism, we will get the correct breathe method called regardless of the actual object we are managing with our animal pointer. If we do feline polymorphism, we can manage our objects through feline pointers, but we will get the correct run method called regardless of which kind of object we are calling this method on. So if we call the run method on a base pointer managing a dog object, we will get the run method called on the dog object. This is what we mean here. Okay, so we have our classes here. Let's take a closer look at our animal class. It is our top level class, and it is going to have a virtual method which is called breathe. It is const because it is not modifying our class here. Notice that we don't have a virtual destructor because I wanted to keep this simple. But in your practical object, you should make your destructors virtual if you happen to have a virtual function in your class here. So for example, we can even do that. Let's make this virtual. This is not going to cost us anything. And this is going to be our top class. We can look at the implementation file. It is not going to do anything special. It is just going to forward whatever parameter we pass and use that to initialize our member variable. I think we can also go in and change our parameter to a string view. So we can do that, std string view. Let's go in the CPP file and also change that pretty quick. We're going to say std string view here. And this is our animal class. We're going to go in our feline class because that's the deriving class. Feline is going to be inheriting from animal publicly, just as we see here. We're not going to really do anything special. We're going to set up a member variable called firststyle, and we're going to forward the data from our constructor and use that to initialize stuff in our class here. Our parameters are also going to be passed as std string view types. So let's do that here. And this is in place. We also have a virtual method which is called run. And inside we are just printing which kind of object we have and giving a hint on the method that is being called here. This is what we just do here. And we don't intend to create feline objects directly. That's why we're not setting up any overrides of the top. That's why we are not setting up any direct specific overrides for these methods, but we will do that in downstream classes, for example, dog and cat, because that's going to make sense there. Let's go in the CPP file for feline and also change things a little bit. We're going to use std string view parameters. Let's do that for the second parameter as well. And this is our feline class. So we can go in and look at our dog class. Let's see if we can find it. And I don't think we made our destructor in feline virtual, so let's do that and look at our dog class pretty quick. Here we have our dog. It's going to have no member variable at all, and it will just forward this data to upstream classes. But we can override our breathe method we get from the animal class. We can do that, and we are going to say, we can grab this entire thing and we're going to go in dog. We can do that if we want. We're going to put this method down below here and we're going to say breathe. We're going to say that this is overriding what we have on top, and we're going to say dog breathe called. This is going to do, and we also need to change our parameters to std string view. Let's do that. This is going to make things work better because we will avoid unnecessary copies and we will be able to pass string literals as parameters to this constructor here. This is what we want to achieve with this. We can hit the CPP file for our dog class and we're going to change the parameters again, std string view, and we're going to say std string view as well here. And we're going to go to the header file again and make sure we have a virtual destructor here, because this is good practice if you are using virtual functions like we are doing here. We can grab our breathe method and hop over to our cat class. Again, remember the inheritance hierarchy we are going after is what we have here. So if you are confused, please come back and look at this. You're going to really understand what we are doing here. We're going to go to the dog class and make sure it is working as we want. So we just did the dog class and we just made sure it works like we want. Now we're going to hop over to cat and make sure it is. Now we're going to hop over to the cat class and make sure it is overriding the breathe method to make sure the correct method is called. Okay, so let's do that. We're going to hop over to our cat class. It is going to have its own meow method, but it can also override the breathe method we get from the animal class. So let's do that. We can grab this and we can go to our cat class. Let's do that. We're going to put in our virtual method and we're going to say cat breathe. And this is really all. We also need to set up our parameters correctly using std string view. Let's do this. Std string view. And this is really all we need to do here. We can also make our destructor virtual because this is good practice. We hop over in the CPP file and change our parameters to be of type std string view. Let's do this. And this is done. We can really work with this inheritance hierarchy here. We're going to also go pretty fast and work on the other side of our inheritance hierarchy. We're going to work on birds. Let's look at the bird class. It is going to inherit from animal. It is not going to do anything special really, but we just want to change the type of our parameters to std string view. And we're going to do that on the second parameter. And we are going to hop over in the CPP file and change these things here. Let's do that. We're going to say std string view and do the same thing here, std string view. And bird is done. We can grab our breathe method. For example, let's go back to the top and grab that from our animal class. And we're going to hop over to one kind of bird we have in our program. We can look at pigeon, for example. The last class here, we're going to override the breathe method. And we're going to say pigeon breathe. And we are going to change the type of our parameters here to std string view. And we're going to do the same here. And let's hop over to the CPP file and change the type of our parameter. Let's do that for the second parameter here. This is done. Let's look at the second kind of bird we have. I think we have the crow class. We also want to override the breathe method. We're going to say crow breathe, and we can go up and change our parameter to be of type std string view, and we're going to do that here. Again, if you are not interested in these changes, you can just grab the code and you're going to have all these classes ready for use. I just wanted to correct this little problem I had in my classes on my drive, because this is not good design in modern C++. We want to do things proper because we are really learning about modern C++ here. Let's hop over to the CPP file and finish this up. We're going to change the type to std string view, and let's do view correctly. And we're going to say std string view on the second parameter, and this is done. Now we have our inheritance hierarchy, and we're going to start by looking at animal polymorphism. Again, we just set up this inheritance hierarchy. Now we are going to try and do animal polymorphism. Okay, so now we're going to hop over to the main CPP file and we are going to clean it up a little bit, remove whatever it is we don't need. We are going to put in our includes. We're going to include all of the things in our file here: animal, feline, dog, cat, bird, pigeon, and crow. We're going to include all this. And we just want to play with animal polymorphism here. We are going to set up a bunch of objects and we're going to put in dog, cat, pigeon, and crow, all kinds of crazy animals we can create in our C++ program, and we're going to put them in an array that is storing animal pointer. And this animal pointer is going to enable polymorphism for our objects that we have in here. Remember, animal sets up a virtual method called draw. If we go back, we're going to find that. And we made sure to override this method in all kinds of crazy animals we can create. For example, in our cat, we have a breathe method overridden. In our dog class, we have the breathe method overridden. And what we want to achieve in our main CPP file, let's go there if I can find it. We want to achieve a setup so that if we call the breathe method, we're going to call the most specific breathe method on our animal pointer here, even if we are calling that method on a base pointer. This is what we want to achieve. And this is going to be animal polymorphism because the base pointer is of animal type. This is what we mean here. Let's try and build this program. So if we loop and call the breathe method, the correct breathe method is going to be called. And what we expect for the first object, which is a dog object, we're going to get the dog breathe method called. For the second iteration, the cat breathe method is going to be called. For the third iteration, the pigeon breathe method is going to be called. For the last iteration, the crow breathe method is going to be called. This is what we expect to see if we run this program here. So let's do this. We're going to pass this through GCC, our favorite compiler. We can use any compiler we want, but GCC is going to do in this case. Okay, the build is good. We can bring up a PowerShell window to play with, and we're going to run Rooster, our program. And if we run this, you're going to see that in our loop, the first iteration is going to call dog breathe because the first object is a dog. The second iteration is going to call cat breathe because the second object is a cat. The third iteration is going to call pigeon breathe because the third object is a pigeon. And the last iteration is going to call crow breathe because the last object is a crow. And notice that we are calling the breathe method through a base animal pointer. And this is what polymorphism is all about. And what we are doing here is animal polymorphism. But this is not what we are really after in this lecture. We want to see that we can also do feline and bird polymorphism in our inheritance hierarchy. So we're going to put in a separator. Let's do stdc out and put in a bunch of dashes here, or hyphens. Some people call them like that. Doesn't really matter. And we're going to play with feline polymorphism. Let's do this. We are going to go down and put in a simple piece of code that we're going to be using to play with things here. And we're going to set up a bunch of objects. We have a dog, we have a cat, we have a pigeon. And we are going to use a feline pointer to manage feline-derived objects. For example, we're going to use this pointer to manage a dog and a cat. But one thing I want you to see is that if you put in a pigeon, for example, this is not going to work because a pigeon is not a feline. So the compiler is going to give you a compiler error. Let's try and do that. We're going to try and put in pigeon here, pigeon 2. We can select this. And if we do that, you're going to see that we get a squiggly line. This is a sign that this is going to go wrong because we are storing in felines and the pigeon is really not a feline, even by our inheritance hierarchy. So the compiler is going to give us a compiler error. Let's try and build to show you the compiler error. Okay, the build finished with errors. And if we go in, we're going to find that cannot convert pigeon to feline pointer. So this is the error here. You can't do something like this. Even if you create an animal object, let's say that we're going to go in and create animal, and we're going to say animal1. We can do that. And we're going to pass in the description. I think we can do that. We can do something like this. And if we try and pass in the address of animal1, let's do that. This is also going to give us a compiler error because animal is not a feline. Again, if you get confused, come back and look at our inheritance hierarchy here. What we are setting up in our code, we are using feline polymorphism, but we want to store an animal in an array that is storing felines. And this is going to be a problem because the compiler isn't really going to be able to process this. Our base pointer is a feline, and we should really be able to only store in derived types from feline. But we are putting in a superclass or a parent class of feline, which will not be able to have the specializations that feline is doing. So the compiler is really saying, this is crazy, I can't do this, I am going to throw a compiler error. This is the behavior we get here. Okay, so this is going to give us a compiler error, and let's run and see that. We're going to use GCC. The build is going to finish with an error, and we are going to see that we have an invalid conversion from animal pointer to feline pointer. And this is what we want to do here. We want to convert an animal pointer and store that in a slot that is only supposed to store feline pointers, so this is not going to work. But if you do everything right and only put in derived types of feline, you're going to get the correct thing to work. And let's look at our dog class. Let's open it again. We're going to look at dog, and we're going to have a run method, but we don't have that set up for our dog class, but we can do that pretty quick. Let's look at cat and see if we have a run method. We don't, but we can set that up. Let's go to feline and copy our virtual function. We can do that. And we are going to go in dog and set up another virtual method, which is going to be run. And this is going to be an override of what we have in our inheritance hierarchy. So this is an override method. We are also going to do the same, but before we go, let's say that this is the dog class we are doing things from. We are going to grab this method again and go in cat, because that's another feline we have in our program. We can do something like this, and we're going to say cat here. Okay, so now let's come back to main, and we're going to build again. We're going to pass this through GCC, and we still have a pigeon in here, so this is not good. Let's take this out and make sure that we only have felines in this array here. Let's build again. Okay, you see the build is good. We can clear and run rooster. We're going to have our separator here, and you're going to see that we are calling our dog method at the first iteration because the first object is a dog, and we are calling a cat running method because the second object is a cat, and this is feline polymorphism in action. Hopefully this proves to you that we can do polymorphism at different levels depending on what we want to achieve in our C++ program. To close off this lecture, we are also going to set up bird polymorphism. Let's do that. We're going to put in a separator, and we're going to say bird polymorphism. And we are going to put in a bunch of objects and set up a base pointer array, which is going to be a bird pointer array in this case. And we're going to be storing in derived objects of the base pointer type. So we are going to be storing in derived objects of bird, and we have a pigeon and a crow, and this is the setup we want here. Now, let's go and look at the setup we have in our pigeon. For example, we don't have a fly method, we just have a coo method because a pigeon coos. If we go in our crow, we're going to see that we don't have fly method, we just have in the cow method because a crow cows. But if we call our fly method, because we don't have this method overridden in any downstream classes of bird, we will get the base version of the fly method called. So we will get this method here called. I want you to see this. Let's hop over to the main CPP file and make sure we have the correct setup. Looks like this is what we want. We're going to build this with GCC. The build is going to be good, as we see here. And we're going to run. Now we're going to see bird fly for pigeon 1 and crow 1. But this is not using any derived method that we have in our crow and pigeon class. If you want, you can also override the fly method and you're going to get that called. Let's actually do that because I like to show you things directly so that you can really see with your own eyes. So we're going to go in bird and grab the fly method, and we're going to override this in pigeon. We can do that. And we're going to override here, and we are going to say pigeon here. And we can grab this and put this method also in the crow class. We can do that. And we're going to say crow here. Now, if we run this program using what we have in the main CPP file, for the first iteration, we're going to call the fly method on the pigeon object because we have the fly method overridden at the pigeon level. As we see here, this is right here beneath our eyes, and we're going to see this in action if we run this program here. The same is going to happen for the crow object here. Let's build with GCC to really prove this. The build is going to go through, we can clear and run rooster, and we're going to see pigeon fly, crow fly. This is proving what we set up in this lecture here. This is really all I had to share. I hope you found this interesting. The main message is that you can set up polymorphism at different levels in your inheritance hierarchy, depending on what you want to achieve in your C++ program. We saw that we could do the usual thing and use the top level class as the driver for our polymorphism, and we did animal polymorphism here, but nothing prevents you from doing feline polymorphism or bird polymorphism as we saw in this lecture. We are going to stop here in this one. In the next one, we're going to see how we can do polymorphism with static members. Go ahead and finish up here and meet me there.